1, and for February 22nd and 23rd. This is the second lecture on Excel. With any luck, I hope to get through some of these worksheets, at least one or two of them. There are three of them total. Uh, and a couple more videos. Anything I don't get to, I'll get to the last lecture, the Wednesday, Thursday lecture. This is for, of course, February 22nd and 23rd, depending whether you have Monday, Wednesday, or Tuesday, Thursday section. We already saw the first video here. It was a pretty basic one. We have the worksheet. I finally got it out of read-only format, and we can go through some of these calculations in Excel, and I think the biggest thing to try to remember is to put that equal sign down. Otherwise, it doesn't understand you. We have some pretty basic, I think, calculations here with addition, subtraction, etc. So let's see if we can do that. If we type in equals 3 plus 8 and hit return, it gets you an 11. It even says it's correct. Let's go down to this green bar here and type in equals 9 minus 4, hit equals or hit return. It's a 5. Now we can type in equals 8 asterisk 7. Asterisk is the multiplication. They put an X there. That is not the Excel way of doing it. Hit return. 56 is correct. 10 divided by 3, well, you can't put the division sign. In fact, I don't even see that on the keyboard. I don't know where that came from. It's been a special keyboard, I guess. And so if we type in 10 slash 3, it will, and of course we do need to put an equal sign. Let's not forget that. I do that sometimes. And so hit return. And then to as many decimals as it gives you right now, it's set for 8 decimals. It's basically 3 1/3, 3.3 repeating. And like a calculator, Excel uses parentheses to correctly perform calculations, especially if PEMDAS is not in effect. It also uses parentheses for special characters, such as pi and e. I don't think we're going to see either one of these. I know we won't see pi. It's very unlikely we'll see x, or e. I don't expect to give you that. We will have logs, but not exp, the letter e, of course. Pi plus 2 is pi equals pi, open parentheses with nothing in it, plus 2. E minus e, well, this is a mistake. It would be exp of 1 minus exp of 1, because they did put minus. That would give you a 0. And this, by the way, will be the power of e. So e to the 1 power is e. Anything to the 1 power is just itself. X to the 1 equals x. So we'll come across that in just a minute. Here we get into the fractions, and we have 25, which is a simple numerator, just one term. It wouldn't hurt to put parentheses down, but they're certainly not needed, so I will avoid doing that unless I really need them. But once again, it's never a problem to put too many parentheses in. It is a problem to not put enough of them in, however. With practice, you start to get a feel for this. We put the 2 plus 3 in the denominator with parentheses because there are 2 terms there. If I hit return, it gives me a 5 because, of course, that is 25 divided by 5, and that is correct. Now this one I don't really know what it is. I know e is about 2.7. These numerators, terms in the numerator, would be about a 5. 5 over 2.7 is almost a 2, so it should be 1 point something. That's how I estimate it. But meanwhile, with kind of a binomial term, if we want the whole thing to be in the numerator, we better put parentheses around it. So rule of thumb, if you have more than one term, you better put parentheses if there's a fraction involved. So now we've got the numerator contained with the parentheses, and now we have to divide by the term for exp, exp1. So this is an exercise. So let's see if that happens to give us something like what I predicted. Okay, they didn't like it, and that's because, once again, I forgot my equal sign. Please don't forget your equal sign in front of the expression. See if I can get that in there. Oh, it doesn't want me to start. Okay, I guess I got to start over again. That's a little surprising. 1.24 plus 3.75, close parentheses, divide by exp, of 1. So let's hit return. Okay, and I predicted it to be almost a 2, and that looks like I'm about right, because 5 over 2.7, 5 over 2.5 would be exactly 2, so the number's got to be a little less than 2. So now here I was trying to estimate if I think it's possible. You've got about a 3, you got a number a little less than 3, so together that's about a 6 with those two irrational numbers, and then 6 plus a regular 3 should be close to a 9. Let's just see how it turns out. Don't forget the equal sign, as I sometimes do. So there's your pi, nothing in the parentheses. We're going to add to 3, just plain old 3. Then comes exp, and this time they do want the 1 in there. So let's see how it goes, and that's very close to 9. Very nice. Square root, yes, you could have occasionally use square roots. Chapter 6, so I'm not going to emphasize it much, but you can certainly do that. Square root of 27 is around a 5, because square root of 25 is 5. 5 minus 2 is about a 3, so let's see how that might turn out. So equals SQRT of the number 27, so simply put the number in the parentheses, and then just subtract 2. That's perfectly okay, because that is separate from the square root process. Hit equals. Okay, we had 5 minus 2 is roughly 3. Makes sense. Well, square root of e, 2.7. Well, square root of 2 is about a 1.5. So this is maybe 1.5 or 2. This number should be between 4 and 5. That's as far as I can get with that one. But we've got to put the equals in because we are asking it to calculate something. 3 plus, and then SQRT of EXP of 1. So here comes the double parentheses. Yeah, this is just the first time that we've shown it to you. So let's see how that turns out. 4.6. Yeah, it's between 4 and 5. Kind of what I thought. 3 plus around 1.5. Makes sense. Here we have our powers. Certainly we don't want to skip them. We've got a few other things to look at in this little work exercise here. So we would take equals as we go, go into this box. Click on the box. And okay, I didn't mean to do that. I don't want to get into that box. Let's go back to this box and type in equals 3 plus. Now we can just run it together and say 4 caret 2. If you'd like to put some spaces in, you may. But notice the exponential is one of the highest priorities in the order of operations. PE for PEMDAS, exponential is the second highest priority. It's going to go ahead and do that first anyway. So parentheses may not be necessary, but it would not hurt to put them in if you're not sure. Better safe than sorry, as they say. I've had a lot of sorry students. Even though it was just a couple of problems last time, it was heavily missed. So I'm hoping that will not happen this next time. Here we have a more complicated situation. Let's see if we can get to that. We'll put in equals 3, and then we have to raise it to, put the caret down for the exponent. This is going to be kind of a complicated exponent. Do not figure this in advance. We should go ahead and just type in as the exponent with parentheses 1.1 minus 2.2 close parentheses. Of course, that'll give you a negative 1.1. And 3 to the negative 1 is around a third. A third is about 0.3. So we should be getting about 0.3. Let's just see how it turns out. Yeah, it's very close to 0.3. Yeah, you really shouldn't go and do the calculations in advance, because if you make a mistake, that's poor. Plus, if I can check your work and see you did some summing up, that's not really to your favor. May not be full credit, in fact. So let's go ahead and put in equals for this next one, a little bit more complicated now. Definitely use parentheses here, even though it's not a fraction. We just have two separate situations. 1 plus 3 squared. Oops, got to put the caret in there. Capital 6. Uppercase 6, and so we put in 1 plus 3 squared. Now we're going to multiply, and here's the thing. Algebra doesn't put the asterisk in, doesn't put the multiply sign in, whether it's a dot or an X or an asterisk, whatever it may be. Excel has to have it. That's where the capital letters has to have the multiply sign. Another one that lots of people make mistakes on because they think, oh, it's just like algebra. Well, it's sort of like algebra, but Excel has to have the multiply sign. So notice I just put the asterisk in. See it? It must be there, or there will be a mistake made, and that will get you basically zilch credits. So let's type in the rest of it in the next set of parentheses, 2 caret 3, and now you can just say plus 5. After all, oops, got to say plus 5, of course, and after all, we do have exponentiation that goes ahead, so no need for extra parentheses, which is nice. Oops, more parentheses there. So let's see what happens. 3 squared is 9. That 9 plus 1 is 10. So we've got 10 for the first term. We've got 2 cubed is 8. 8 plus 5 is 13. 13 times 10 is 130. So this should be 130 exactly. And it is. But I'm interested in seeing what would happen if we typed in something else. Well, if we just typed in, say, 1 plus 3, and let's just forget about the squares. Let's just put them back to back to show you what people will make mistakes on. I'll put a little bit simpler problem, but now it's not going to understand you because we found a typo in your formula and tried to correct it. So they're suggesting, if they're nice to you, they'll suggest putting in the asterisk because this is such a common mistake. But if they're not nice to you, or especially if it's more complicated, or you made more than one mistake, which has happened, I've seen many people make as many as 6 mistakes in a fairly basic Excel scenario. So if you make more than one mistake, you're probably out of luck. So don't count on this to save you. So I could say yes, and then it would do it. Of course, this is a different problem. I did 1 plus 3 is 4, and 2 plus 5 is 7. 4 times 7 is 28. So that was just a different problem. You should be experimenting with this on your own Excel sheets. So let's try this one now. We've got parentheses, and I'm going to need pi. So pi strangely has the set of parentheses like that. Got no choice in that. That's what Excel decided to do. So now I'm going to close up the parentheses. Notice I put parentheses around the pi and parentheses around the minus 1.3. That is your entire numerator. Don't be distracted too much by those extra parentheses. Now I have to put a backslash, and yes, do not add those numbers in advance. You're defeating the purpose and would not earn full credit if I was able to check your work, which I may be able to. I'm still working on that. But the idea, just in general, is not to do all the work in advance. Otherwise, why bother with Excel? You know, Excel is supposed to help you. And I forgot to put the equal sign. See, I'm notorious for that, so I don't follow my own advice. See if I can slip a thing in there. No, it doesn't want me to do that. I just have to start over. So sorry to waste your time. Got equals, and I'll do it again. Pi minus, and I've got to put parentheses, and then minus 1.3. It does have different colors. That's helpful for extra layers of parentheses. It'll often do different colors. I like that. So then, of course, as we just did, 5.8 plus 2.3, 2.6, sorry, and then we can close the parentheses, hit equals, and we're good. Okay, I did not approximate that one. So here we have another one. Don't forget the equal sign. Put in the 3. 3 is just by itself. And now we can subtract what will turn into a fraction, which typically needs lots of parentheses. So let's go ahead and put that in. 1.6 plus 3.7. Do not do this in advance. And then we can divide that by simply 4.3. A simple number does not need parentheses. Doesn't hurt, but you don't need it either. So let's see how that would do it. And 3 is all by itself. And I could put extra spaces to emphasize that, but I'm running them together, just my habit. So 1.7 seems reasonable. That's about 5 over 4, so that's about minus 1 something. So 3 minus 1 and change gives you a little less than 2. Okay, that sounds right. So let's try this one with the equal sign. Type in the 3,000. Do not forget to put the multiply sign down every single time you multiply. Excel has to have it that way. Sorry about that. I wish they didn't do that, but they need it. So 3,000 will be multiplied by, in parentheses, 1. And I'm going to go ahead and say plus. This one's kind of a borderline call, but I'm still going to follow the Excel model. Of course, the leading 0 is not necessary. And we're going to need to raise that to the 5th power. So caret 5. Notice the exponent only goes to what's in the parentheses. It does not go to the 3,000. 3,000 to the 5th power would be some huge number, undoubtedly in the trillions or quadrillions. So if you get a number that's way too large, you've made a mistake. There's a kind of a clue there for you. So hit return. That seems about right. This is like 12% interest, simple interest per year for 5 years. Takes your $3,000 up to over $5,000. What about this next one? Well, let's see. I wish you could work on these. I wish I had a way of sending them to you. Maybe I can try to do that. So we have 372.5 times, and I'm going to just say 10 raised to the 3rd power. Don't type in 1,000. Try it this way. Let Excel do the work for you. Now this one is quite handy when it comes to situations that don't divide by 12 very well. I avoid those on tests. So I'm trying to get you a little bit of help in case you're not into Excel too much. I know we're not going to give you a lot of time to sit down to learn it. I've got to type in 1 plus. I'm going to type in 0.05, and I'm just going to divide by 12 because that's self-contained, and dividing will go ahead of addition. That's multiplication, division, then addition, subtraction. So no extra parentheses are needed here. This is self-contained division that is done pretty early. So got to close that up and raise it to the 30th power. So, oops, got to put the caret in, of course, caret 30, and that should do it. This gives us about, a certain amount over 30 periods, probably 30 months, almost for sure 30 months. So let's hit return. Now we get about 13% more than what we started with. If 1 is your principal, you have 0.13, about 13% extra. Let's see if we can try this. They've got a couple of misspelled words. Calculation. I think they meant calculation, didn't they? Anyway, I'm not going to worry about typos like that. I certainly make my own. Certainly use cell references to do the corresponding calculation. Use the calculation in the green cell. Remember to use the equals in front of the arithmetic expression. Of course, I've got this star and everything else. So we are in the mode where this is F100. And we're going to try to add what's in C100 plus D100. So I'm going to try to type in equals C100 plus D100. It doesn't have to be capitalized. I'll type in 100 and then plus and then D. Didn't mean to caps lock it, but I did. 100. Let's just see what happens when I hit return. That's a 20. Very nice. Now if I could somehow drag this down, so if I get to the formula bar, well, maybe let's start it here. How about equals C101, because this is now row 101 and column C plus D101. Now, before I hit return, let me see if I can drag it and see if it works as advertised. So if I could just sort of pin it down. Okay. Well, they're saying it's incorrect. Clearly it is correct. So yeah, so I'm not getting too well on this. So well, that was subtraction, of course. Yeah, that's my fault. So if I click on it again, let's see. If I can get back here, I can then change it. And it's in fine print, so you may not be able to read it. But I need to put minus D101. And yes, the formulas will be changing now, so that's why it's not going to be the same. But 15 minus 3 is 12. Yeah, I got to read the instructions. And multiply, otherwise known as multiply. Well, what we can do now is to type in, we're not going to be dragging anything, just type in equals, and now we're in row 102, so C102 times D102, hit return, and 3 times 6 is 18, so we're using cell references, of course. And we're in 103 now, so equals C103 backslash D103, hit return. 10 divided by 2 is 5. Now we can add a string of numbers in row 104, so we'll take equals C104 plus D104 plus E104. Covers a lot of ground. Notice how the colors change from blue to red to purple. Let's hit return. And 4 plus 8 plus 1 is definitely 13. And one more here we have equals C105, and type in the 5, and we're going to multiply that by what's in D105, and then let's not forget E, because we do have an E column as well for a third number, if any. We do have a third number, so multiply by E105, and I got to get an E in there, not a 3, of course. So there's your E, and now let's hit enter. I don't know what that's doing, but let's hit enter, and yes. 2 times 3 is 6, and then 6 times 4 24. That is correct for sure. So like most college students, you're probably on a tight budget. Yeah, yeah, lots of us are. Let's say you want to buy hot Cheetos Puffs. You go to Walmart and find a 3.38 ounce bag costs $1.48, an 8 ounce bag costs $2.98, which is the better deal. And we can do unit pricing by taking the dollars per ounce, $1.48 per 3 some ounces, and take your dollars $2.98 by $3 divided by 8 ounces, and we can see what the better deal is. And the better deal, by definition, is the one that is cheaper per unit price, unless you just like spending lots of money. So instead of doing the division, I'm going to type in the cell references. Cell references is what they're saying. There's a typo there. I should talk. I haven't gotten these things together, and they have. It's just they're probably in a hurry. So we'll have the row 113, and this will be column B. So we'll type in B113, and that will be the dollars per ounce. So we'll divide by C113, its neighbor, and let's see what we get. Okay, that's 37 cents and a little bit more, 37 and a quarter cents to be exact. But 0.37 may be enough. Let's go down here and check out the cell reference down here. We're on to 114 now, and B114 is divided by C114. Let's hit return. And now we find that $1.50 per 4 ounces gets you about 44 cents an ounce rounded. So rounded to the nearest penny, 37 cents an ounce for the bigger bag, 44 cents an ounce for the smaller bag. And that is a good rule of thumb. Doesn't always work. I'd say it works 90% of the time, where the more you buy, the more you save. That sounds like a publicity slogan that I've heard a few dozen times. But yeah, that's generally the way it goes. Once in a while you get exceptions because there's a sale or something, or they have too many 6-ounce bottles of something versus the 18-ounce bottle. But that's a bit rare. You can find it. Typically, many stores give you unit prices already, so you don't have to worry about it. So what I'm going to do is I'm going to type the answer in the green cell as the big bag. I guess I'll just type it in the way they called it, and then hit return and see what happens. It's correct. So that was just not a computation type of situation at all. Okay, so we got getting started with Excel out of the way. That's the first spreadsheet, so let me get out of here. And I don't want to save anything, nope. So let's go, and then we'll try the next one, cell addresses, is that right? Let's see, let's go over here, and that's number 1. Here's, okay, I got to get out of read only. That was the problem I had before. So I think this is going to be a copying and stuff. So let's see about that one. And I think this is going to be number 2. Let's see. They don't really let me read it. So I'll download it and we'll get into what it is. And I believe this is number 2. Yeah, so I've got to get back up here. And this is number 3. Okay, I don't want number 3 right now. I want number 2, so that's going to be cell addresses. I'll download this one. Sorry to waste your time here. I'm unable to pause the recording because I got to double click that. Okay, so I can get to cell addresses, and so this one will be there. And so now what we're going to do is take a look at the video first, and that might be better explanation than I can give you. So let's go ahead and click on that. And that's okay. So maybe I'm in the wrong mode here. So let's pull that somewhere else. Skip verification. Okay. Anyway, maybe it'll just play now. Okay. Yes, it will. Good. So I'll have to comment because they will not provide the video or the audio. They will provide the video only. So here I will try to paraphrase what they're saying. Learning, doing, and using math. So we're using cell addresses, which we started to do already. So we put the numbers in the cell, such as A1. There's a 5 in the A1. There's a 2 in the A2. There's a 3 in the B2, that kind of thing. Cell reference is another name for cell. So we type the address to create a formula, and we started to do that already. Start with equals every time. They're using the A1. There's a 5 in there. They're going to add the 2 numbers, A1 plus B1. We just demonstrated that one. Of course, you get a 12, and it's, by the way, it's placed into D1. You don't have to say that. You just go there, and it'll do it for you. Now, if you change the numbers, it'll automatically do it for you. Suddenly, it's 507. Because the formula is still there, and you can then lock it in, and the formula is locked in, the numbers will change. So 500 plus 7, 507. So it updates in case the prices have changed or something like that. So we did the unit price just now. We can take a look at how they have it done here. So one box, the big box is $3.99, 18 ounces. The smaller box is $3 for 12 ounces, $2.99 to be specific. Okay, so we can type in headings all you want. That part I'm not too concerned about. But yes, it can be quite helpful to get yourself organized, and you can put the units in and everything. You can always abbreviate if the abbreviations make sense to you, or maybe to me, that's fine too. So we're typing in all the data from the prior situation, and we put in the price, almost $4. The 18 ounces are put into cell C14, and we put in the price of the small box, including the dollars, and 12 hours in, and we can then divide it in 12 ounces in, that is. So it looks like the first calculation, we're going to have to type in equals B4 divided by C4, C14, B14 divided by C14, excuse me, that's row 14. So whatever happens to be in cell B14 will be divided, because it does say dollars per ounce. That is important. So the units actually helped you here. And that it's not ounces per dollar. Sometimes people get it backwards. That would be, or upside down. That would be not too good. This is rounded to the nearest penny, by the way. Sometimes you get virtually a tie and you need to go for another decimal. The other format was in a format where it just gave you whatever decimals you needed. I'm pretty sure this is not exact. This is a rounded number. But that's okay. Even though it was a close call, the small box was a little bit more expensive, as what typically happens is 25 cents per ounce. The big box, you get a little bit of a price break, so it's 22 cents per ounce. It's because they get you to buy more that way. It didn't say you had to use it all. But assuming you use it all, that is a better deal for you, unless you just get tired of cornflakes and don't want to have them. Mistakes in typing numbers are easier to see when you have them in a formula. It's easier to work on versus just typing numbers in. Numbers will change. Somehow you've found the numbers are wrong, or they're updated for the new year. Typically they go up slightly every year because of slow rate rising inflation. And so it would be all ready to go. So type in the number just once and you'll have the formula already set to go. So here she's talking a little bit about what's in the price column and what's in the big box row. Right, so putting headings on is convenient in case you save these files and need to use them again, kind of forgot what you did in the future. Here we have three different parties, Republican, Democratic, and Green. There are many other parties, of course, but according to this election in a small area of the country, you can see the votes that came in, and we can see what proportion or percentage would be for each of these. So what we have to figure out, we have to get the total of all three of these. So in this case, it's going to be cell B25, cell C25, and cell D25 all added together. So as you see here, we add B25 and C25 and D25. And that's a total of 592. If you want to get the percentage or proportion, you then divide these numbers by the total. So we'll take, say, Republican will be in cell B25, and it'll be divided by what's in E25. So type the address in for future results in the future. And it's in E25. And there it is. This is not a percent, by the way. This is a proportion. This is a very small mistake. You could then go into percent mode. It's right at the top of the screen. I'll circle it here. And then you go to percent if you'd like. Now, Democrat percentage or proportion takes C25 over E25. The Republicans won here, but did not get a majority, depending on the format. There may have to be a runoff, I don't know. So here with the green, D25 is divided by E25, and that's going to be a smaller proportion, about 9.8%. These are proportions, not exactly percentages. They haven't been multiplied by 100 yet. To me, they're virtually identical. I don't mess with the difference too much, but it is slightly mislabeled. click on the percent button, which is up there. Click on it. So they're going to do that now. Hit percent. And notice the green box is already highlighted. They decided to round to the nearest whole percent, which I don't prefer. I'd rather have 1 decimal place on that, or maybe 2. And you click on that, you get 10%. Sometimes the total will be different than 100 because of round off error, but this one did actually add up to 100. And so what they do to check on that is to type in the cells. Oh, okay, so this would invite round off error. I'm not in favor of this plan. I don't think this is a wise idea, because way too many times there's round off error, and there's nothing you've done wrong. It's just the way the numbers stack up and the way they've rounded. And it'll happen. So here we have another shortcut that she's going to explain here. I'm not sure how relevant this might be to us. We're getting close to the end of the video. Let's see what she's doing here. And of course, you can watch this video again with her more expert commentary. We're going to type in cell A1. And all you have to do is just sort of click on it. And it's got a little swirl screen around it. And it just types it in already. It's going to be very handy if you get way to the end of a spreadsheet that has very complicated cell references. Yeah, they've got color-coded, the blue for the A and the red for the B. Right, so point at it. So just point at it, and that's how you can get a little bit of a savings on that one. Okay, so that would be the end of that one. Let's get out of this one, and let's try something else. I'll get over to, I believe, the last video, and let's see if I can do that. And that's number 1. Here's number 3. And that's number 2, rather. And here would be number 3. Okay, I believe, well, I can get it over here. It's copying. I want to get it out of read-only memory because that would be not too good. Okay, so let's try the last video, and then I'll be done with the videos. Won't have to show them in live classes. This is the last one, copying and filling, a little bit more advanced. We haven't covered this too much yet. It's a little bit longer. So here we go with right, so this goes back to the cheese example. So you set up a formula, so you only have to calculate it once. So this would be exactly how to do it. The book hints at this. So perhaps it's just $4 a pound now instead of what we said in the book, $4.95, I think it was. So we can set it up to get all the cheddar cheese sales and what the price involved was. So pounds of cheddar cheese versus cost, and so we're going to see if we can get that into the Excel spreadsheet. The person got 1 pound of cheese, so just type the 1 in there. But the cost, so we'll use a formula for the cost, and we'll be using this over and over again to save time. We'll just sort of type it in once. We know it's $4, don't have to say 4.00, and times 1 pound, but instead of typing the 1, let's just use cell A2. And that gives it to us immediately, and then it's ready to go for more calculations too. So by 2 pounds of cheese, so instead of retyping the formula, we can copy it. So we can edit, copy, and it spins around, and then paste it, and then it already got to 8. And you can drag it down and get several at once, but of course there's not much in column A yet, so we can't do that yet. So now it's already changed it for you. The blue writing A3 has changed from A2 to A3. Yeah, if it copied A2, then we'd be stuck on $4 no matter how many pounds people bought. They buy 100 pounds to still pay $4. Yeah, I think that person would probably go out of business after a while, giving away a lot of basically free cheese. So this is a nice one that it changes the formulas for us. Okay, let's see what happens with the third person in cell 4. A4. So they buy 10 pounds of cheese. That's a lot. Cheese wheel maybe. And so if we can copy and paste. Okay, keyboard shortcut. Give that a try. So we type in a bunch of pounds of cheddar cheese for different customers, different decimals perhaps. And so we have many different numbers, all positive numbers. So let's take a look at this shortcut. It's called filling. So we grab the bottom. Let's see, the tablet's different. So we've got the one that we're using, which is the third one, which is correct. 10 times 4 is 40. So we get the lower right-hand corner. They're zooming there to show you where that little square is. We can kind of drag it. So make sure it turns into a different color. And drag it as far as you need and all the way to the end of the data. If you go beyond it, it just probably give you zeros or blanks. So that was very fast, wasn't it? And you can spot check. A fourth of a pound times $4 a pound is $1. That's easy. And they have all the cell references changed, all the A's. It's now A5 instead of what we started off with, A2. You don't have to retype it over and over. Yeah, so it seems to be collecting everything. Another easy one, 4 times 3 is 12. So that's actually very easy to get. So that's very handy. Just grab the bottom right corner, look for the square, and then drag up to where the data ends. Yeah, if you go a little too far, it'll give you a 0. So it does have the A11 in there, but right now A11 is considered to be a 0, which makes sense. So if you get ready for future customers, it starts off with 0, and then as you type in some other numbers, it might change it automatically. So she's going to type in a 0.5, and automatically it gave you $2. So it's all ready to go, no matter what quantity you put in. Should be a non-negative number, reasonable number. You can't give away hundreds of pounds of cheese per person, but anyway, they show you how fast it can be. So this is for tablet use. This part I'm not so sure a lot of you will be using, so let me advance, and you can watch this if you need to. This is more on tablet or phone, so as I continue, just see how this one goes. Yeah, iPad, continue, and it's just very similar operations. Okay, so let's get to the end of the other portion. We'll get to the last couple minutes of this lesson as we get back to the Excel spreadsheet on a PC. Input and output. Input would be X and output would be Y. They put the headings there, and we can show a particular polynomial function. Here it is. It's a parabola, of course, a second degree equation, upward facing because we have a positive in front of your X squared. And you could put in a value of -3. And the book even shows how you could create some graphs. I don't think we're going to get that involved here, but you can certainly look into that if you're interested. So we type in row cell reference A3, and we're just going to add 0.5 each time. And then we can drag it. She's even illustrated this with a number line. And so as we keep adding a half each time, we move along the number line slowly but surely until you get to the point where you want to stop. Right, so we can then drag the cell reference down, or copy if you'd prefer, but she's going to drag it down and just add 0.5 to every X value for quite a while, a little bit too far, and then you can see how we went from the negative zone to the positive zone and just counting by 0.5 each time. So you can see it down here, especially when they get to be positive. So now we have to get the formula in there. So for every X value, we come up with Y values and then perhaps even do a graph after that if you were so inclined. So we have to use the X value as A3, which is where we started. Type in equals for the calculation. We'll use our cell E3. We don't want to type in the -3. That's not going to help us much. So we'll square it. That's what the second power does. And we'll subtract 3 times X, and we have to put the times symbol in. Otherwise, it will not understand you. So important. So many people missed that last time. I have to keep saying it over and over so you can finally not make that mistake. So don't make that mistake. And put extra spaces in if you want, but minus 3 squared to be a 9. Minus 3 times minus 3 is another 9. 9 and 9 is 18. 18 and 5 is 23. So I can see very quickly. And now she does actually explain that. And let me see if I can pause it, because she does tend to go fast sometimes. Minus 3 completely squared gets rid of the minus sign, gets you a positive 9. And ironically, it's the same calculation from a different angle, I guess. And that's another positive 9. And you add it to the 5. Yes, that's your 23. So we'll get a few more calculations in here as we play it. And let's try. Of course, the ones with the decimals will be a little harder to do by hand. So this is helpful to have Excel do it for you and do dozens of them at once. So click and drag, and you can drag all the way down to the bottom, or even further if you want. And so now we're getting up to the thousands, as you can see at the end. And it kind of mins out at 2.75. That would be the vertex. That's the, and it starts to come back up symmetrically. But that's just what a parabola does, as you've probably seen in the past. So we certainly have that available to you. Okay, so we can pause that or get out of that type of mode. And so that's the third worksheet, and I can get out of that now. And let's see if I can go back to where I was. Mail. Okay, so here we are, section 3. I think we're in read-only mode, but they have something that the book starts to explain. I may save this for a little bit later. It does look interesting, and yet that's going to take a lot more time to explain. I think what I'd rather do is my last amount of time here, I don't want to go too much over an hour. I can go into the book part, so I had that queued up. So let's see, do I have, oh, it logged me out, I guess. Yeah, it didn't. Okay, that's not what I had in mind. So let's see, I guess I better quickly do that. And I'll go ahead and get my, yeah, sorry about all this. So it's going to take just a moment for me to do it. You can't see my password anyway, so I guess that's not going to be a big deal. Okay, it's signed in. I wish I could pause this. So as I get into my Cengage account, I will also show you where you can find book resources. In case you're still challenged by that, you can certainly look at this. And I'll just pick the first section. Notice I have 4 sections of Math 1101 and another class as well, more of a heavy-duty stats class. So I'll just pick section 8. It really doesn't matter which one it is because they're all the same. And I'll go to the book resources. And I'll go to the spreadsheet basics for doing math. And that is, of course, the part of the book that's been written by Dr. Addington. So we left off last time on example 2. I can probably increase this a little bit. Yeah, so we can get the size just a little bit bigger. And this is kind of what we did before. We're just a review here. Make a list of months from 1 to 360. So we just find the fill handle. That's what they call it. It's that little square in the bottom right corner. And you can type in, that might be a mistake. I found if you typed in A1 plus 1, that would work better. So instead of, this looks like a mistake to me. A1 is what's in cell A1. If you keep adding 1 and then drag it down, that would work for you. I don't have a demonstration of that, but they say hover over the corner until it changes shape, and then you'll see the little X change colors, and then you can drag it down. And yes, that they made a mistake. So it's really equals A1 plus 1. And this will then, of course, change the cell numbers, add 1 every time, all the way to 360 if you want to see a full mortgage table. So much fun to look at. The best part is at the end when you start to pay it off. And of course, you have tablet and phone instructions. Feel free to read those if you want to. They also have something that we haven't been using much, but just in case you need to prevent an address from being changed, you could look at that as well. So I'll say a few words about this. I don't know if I'm going to go too much into this, I guess, but I guess I can say a few words. They call it absolute cell references versus relative cell references. Let me see if I can clear this up a little bit. When you copy a formula, all the cell addresses are changed to reflect the copying. So if you move it over, we haven't been moving over different columns, but we just going down the same column. And maybe there's one cell at the top where you type today's price of cheese, and maybe it changes every day. So you can put a dollar sign before either the row number or the column letter or both in a cell address to prevent that part of the address from changing when being copied. So yeah, in other words, it'll keep that one price locked in. So D1 is sacrosanct, I guess is the word. You don't want to change that. And although you do want to change the reference point, I guess, just take whatever's in cell A and multiply by 379. And then this way, if you needed to change the price all at once, you could do that. So there's an advantage there. So this looks rather complicated. You put the dollar sign before the D and before the 1. You can do kind of a hybrid of this, but I just haven't had any need to use that. So this does give us various values similar to before, but here's the advantage. Say the price of cheese goes up, which it does sometimes, and instead of having to change all the reference numbers, you could just, with the cell references that we have, this one column has been changed from 379 to 429, and this will lock it in. And just change one column and everything changes at once. Change one cell, that is D1, from 379 to 429, and it changes all of them. The easy one to see is the £1 at 429 per. So that's the total cost. I thought we could use some of this here. And yeah, by the way, if you need to just, change the row number, you could do it this way, where, $C2 or $2 will change the column letter only. So anyway, just in case you had some need for that. Here we have rounding with dollars and cents. I believe it does that automatically to 2 decimal places. But if you need to round to some other level, you could do that. If you have the number 654.321, you could type in round with a 0 following it. That rounds to the nearest whole number. Very easy. This one's for dollars and cents, I suppose, if you can't get it to work any other way. You type in your number, it'll round to 2 decimal places. In other words, the 1 and the 3rd decimal place is truncated because it's between 0 and 4. This one's a little bit trickier. A -3 means you have to round not to the nearest dollar or nearest penny or whatever, it's to the nearest $1,000. Notice there are 3 zeros there. And 654 is beyond the halfway mark, beyond 500. So yes, that kicks up to 1,000. If it was 454, it'd round down to 0 at this point, because to the nearest $1,000 bill, it would either be $1,000 or $0. Sounds a little weird. We haven't done much of that, but just in case you had need for that, you could do that. Don't know why you'd always want to round down or round up. Certain business calculations actually do use that. I've even heard of rounding to the nearest even number, but that's very specialized situations. Maybe if you're an accounting major, you'll find out about that sort of stuff. Sum's pretty easy. Just takes all the numbers inside the parentheses and adds them up. Or you can go from certain columns. They say in the example above that's a mistake. There was no example above that used that, so it must have been from a different edition. Incidentally, I didn't get through the fact that if you type in A1 colon A4, it means take all of the ones in between, A1, A2, A3, A4, and do whatever you need to do. So in other words, sum of A1 through A4 will add all the numbers from A1 through the numbers in A4. Just add them up. And in the example above, I guess that you could say that that's the example above. Okay, that's fine. So the maximum, the largest of the numbers listed, so I believe we did have a mistake here somewhere. Yeah, the maximum number between 5, 2, 44, 1, 2, and 9, that's not 1.2. I think they got that's the minimum. So these two numbers are switched. The maximum number is really 44. So I wanted to point that out in case people are reading and got to get past these mistakes at least, if nothing else. So 44 is the maximal number. And we do not have these columns to really take a look at. So the 13 is an unknown number. I don't know where that came from. But the minimum of these same numbers, of course, is 1.2. So they got these two numbers switched, as I say. And we don't know about this because we don't see the set of numbers. But apparently there was a 1 there that was the smallest. And then if you are not sure to see if these numbers are equal, you could actually put equals H1 equals I1. And if they are the same, perhaps it's to like the 20th decimal place. You don't feel like looking at all the decimals, or some other situation where some algebraic expression is maybe equal to something else, but you're just not sure. And so you could just say true, false, and it'll say true or it'll say false. And then you could even do greater than or lesser than. So if a number in J1 is greater than K1, turns out that's false. We do not see the number, so we can't check it. But then, I guess by default, J1 is then less than K1, or true. So if it's equal, I guess they would both be false. And they do save numbers, save work if you're looking for certain numbers in a list. Instead of scanning the numbers, you can just scan for true or false. That could be quite much quicker. So I did want to say a few more words as we get ready to close up shop. Maybe we'll save the financial math and spreadsheets for a little bit later. Here's some things to check if things aren't coming out right. If you're spending a lot of time doing things over and over, typing rather than using formulas, yeah, try to use formulas as much as you can. If you see a pattern such as adding 1 each time, definitely use a formula. Assuming the program can read your mind. Computers don't do that. I found that out a long time ago. It may seem obvious to you. You better make it obvious to everyone, including your computer, or it's just not going to do anything you want it to. And I'm sure a lot of you already know that. Figure out what the pattern is. If you think it's a different kind of pattern and it just isn't the right one, it'll just give you the wrong numbers or just give you an error message. Not checking that you gave the right instructions to do what you want. It's tempting just to move on after you've entered and filled a formula. But if you haven't checked it, you can see all kinds of things spiraling out of control. From very subtle, small round-off error all the way to numbers in the trillions of dollars or negative numbers that don't belong. You changed the first cell, but forgot to change the filled cells. So if you enter a formula and filled it down with using that bottom right corner, and then you decide you change the formula and change it on the top cell, if you check, the formulas are still copied from the old formula. You have to fill the new formula down. So that's important as well. So you got to grab that corner and pull it down if you change the formula. That's something I almost forgot. So using relative cell references versus absolute cell references. So they talk about that, and you could put in the 495, and I saw let you read all that part. But yeah, we're not going to really have any need for a hybrid situation. If you want to lock something down so you can just change one number and everything else will change, type the $ before the letter and the $ before the number. Failure to read the manual. I still like reading manuals myself. It helps. Sometimes just don't get me the help I want. Whereas a manual, I can typically figure that out. I guess that goes back to my old days as working as a student assistant in the library at Cal Poly Pomona. I could whip through a book really quick and find the page number. I was really good at it. And I've just never developed that skill with computers as much as I did back then. I guess I'm just an old timer. Anyway, I'm not going to cover this today, but we do have something that is interesting, something we've been covering, amortization tables or whatever. You win $10,000 and you get 6% computed monthly, which is, of course, 0.5% per month. And we can see how the table will be generated. Feel free to read this at your own leisure. You may find this helpful for the exam or just for your own general information. Okay, so I think that'll do it for today. We'll let you go, and we'll be back live on Wednesday and Thursday with a little bit more on Excel, especially designed for Chapter 4. And this example here has a hookup with Chapter 4. We'll see how much time I have to cover it. But I do want to spend about half the time talking about the exam too. So let's go ahead and let you go, and I will sign off for now. Have a nice weekend, or have a nice week, I should say, and we'll see you later. Bye-bye.